Hello, this is Jason Clement, Technical Sales Manager at Isonas, and welcome to this advanced training module. This module is Isonas IO Modules. Our course objectives are: understand what IO modules Isonas works with and how to configure them, understand and configure IO supervisors, IO groups, and output business rules, understand and configure individual inputs and outputs as well as IO types. Isonas IO Modules. Isonas uses standard Modbus modules. There's a bunch of advanced Modbus protocols out there and we are not compatible with those, just the standard Modbus protocol. These modules reside on a network and an IO supervisor communicates to them. The IO supervisor is similar to the communication supervisor or CSUP, except that it communicates to IO modules instead of reader controllers. The IO supervisor polls the devices to check for changes. These polls happen multiple times per second or as configured to check for status changes. There's a feature in some modules that allows for changes to be seen if they happen between polls. This is called latching, and we'll see that later on in the module. Our resellers have been successful with Advantech, which is shown to the left there, the Atom 6060, C-Level, and Acromag modules. The modules can be used for things like elevator control, monitoring additional inputs, controlling locks with no readers, etc. Basically anytime you need additional inputs and outputs to the system that are above what either the IP bridge or the PowerNet reader controller provide. So let's take a look at how the IO supervisor works. Here we have a PC running DBCrystal with an IO supervisor. This is communicating over the network, and we have an IO module sitting on our network as well. This has various inputs and outputs that are connected to it. The IO supervisor is continuously polling the IO module to check for any changes. We're going to send commands to that module. These commands could be a script, business rules, etc. For example, one input could be a lockdown button. When the button is pushed, it locks down a door group. This is handled by the CSUP, but also triggers a couple of relays on the Modbus module for alerting within the school. These outputs could be a series of strobes, it could be an output tied to an alarm panel to notify the police, and so on and so forth. Choosing the right IO module. First, make sure to purchase a module with an Ethernet port. There are some IO modules out there that still use RS-485, RS-232, and other protocols to communicate. We really need the Ethernet. Analog versus digital inputs. Digital inputs are the most prevalent in security. They just look for a basic state change, i.e., an open to close, and vice versa. Analog inputs are more rare in security. They look for the absence or presence of voltage to determine if there's been a change in the state of the input. Outputs. There are many types of outputs available in IO modules. Typically, you'll want to look for a Form C relay output. Sometimes you can use a read relay or a Form A relay, which is just normally open in its normal state and normally closed in alarm, will work. There's other types of outputs such as TTL, open collector, and digital outputs. Most of the time you'll need a Form C, or sometimes you can get by with that Form A relay. So what are the configuration steps? First, we need to configure the IO module. We're going to use the software from the manufacturer to assign a static IP address. If desired, you can change the port as well. We need to confirm the addresses of the inputs and outputs on the module. We'll need these to program into DBCrystal. Then we'll need to configure the IO supervisor. This is similar to a controller supervisor and can run as a service. Then we need to add the IO module to DBCrystal under the IO supervisor. We're going to right-click on the IO supervisor and insert. We'll enter in the IP address, port, and IO point addresses. Next, we need to configure the points. We're going to configure them with a name, an IO type, etc. And we'll see all the configuration options when we jump into the software. We'll need to configure IO groups if needed. IO groups are used for such things as elevator control and arming/disarming a group of inputs at once. Then we need to configure IO profiles if we need to. I/O profiles control outputs for elevator control and output business rules. Then finally, we need to configure output business rules if needed. Output business rules are used when we need to trigger an output on a schedule. For example, an electric lock only door that is open during business hours. Now let's jump into the software. So here's my copy of DB Administrator running, but first we want to take a look at the Advantech utility that we use to configure the I/O modules. I already have a static IP address assigned to this module on my network. From this screen, I can see the status of the inputs and the outputs. So in order to test things, I could actually just come in here and trigger my digital outputs. I could also see the status when my inputs change status. Very simple and an easy way to test things if you don't have communications to DBCrystal yet. Underneath each input, there's a couple of settings that I can change for use within DBCrystal. There's a mode called latching, which we'll see configured in our software. Typically, we'll also invert the signal for best use with DBCrystal. So I can go in here, choose my digital inputs, invert my signal, and apply to all. And that'll take care of that piece of it. When we get into DBCrystal, we'll talk a little bit more about latching. In order to configure latching, we would come in here and we would say low to high latch. For now, I'm just going to leave it at a standard digital input. So in DBadmin, we're going to go to our I/O module, and we're going to create an I/O supervisor. So we'll go ahead and insert that, and we'll go ahead and call this building A. Perhaps we have multiple buildings within our system here. We'll leave the rest of this as it is. Click OK. And we have our I/O supervisor. Now we need to actually configure our I/O module. So I'm going to go ahead and just start the supervisor right now. Now it's running. And of course, in any live system, you'd want to configure this as a Windows service. Now let's go ahead and insert our I/O module. I'm going to call this our Adam 6060. Under connection, we'll put in our IP address. In the C-level units, you can actually have one Ethernet unit and then multiple units connected via a proprietary protocol off of that main unit. With our Adam module, we don't have that, so this is just going to be unit 1. We have 6 input points starting at address 0, and we have 6 output points starting at address 16. And I know this because of our knowledge base article on elevators, which includes some Adam 6060 configuration. We'll go ahead and choose our Adam module here, and we'll click OK for now. Now we'll go back to here, we'll expand this out. So I had to stop and restart the services here, but now we see our Adam module is up and connected. So now we're going to go back under our I/O module, and we're going to configure some of these inputs and outputs. So our first input we're going to call side door. Now we're going to go ahead and configure a type. So we don't have any I/O types by default. You can create these however you like. So here I'm going to go ahead and say that this is a type 30, and it's going to be our door contact. So any other door contacts in our system, we're just going to go ahead and choose this type 30. And then within DB Monitor, we can actually filter by type or points that are greater than or less than types. So for example here, 30 may be a low number within our system, and then 80 or 90 may be higher priority items like panic buttons and things like that. Our normal state is off. Recheck count. If you have some existing contacts that are coming in over maybe some noisy wires, it could cause potential false alarms. So if you set this recheck count to 1, 2, or 3, it'll actually double check to make sure that that point has actually changed state before it'll trigger an alarm. Our authority level required to operate this point. Of course, we need an authority level higher with our login than the number of the authority level listed here to be able to manipulate this point. So here with an authority level of 0, pretty much anybody could manipulate this point to arm or disarm it. Our on suffix, we'll say door open in the monitor station. When it goes off, it is door closed. And we'll go ahead and select that point. Now we take a look at the latching. So I'm going to go ahead and click OK here for now, and we'll come back and edit that in a second. The I/O modules are pulled every so often. So here by default, it's going about once every second. I'm actually going to change that, and I want it to be once every 1/10 of a second. Well, what can happen is that in between these pulling intervals, your contact could actually change state and go back to its normal state, and our software would not see it. In order to alleviate that, we can turn on latching. So if we go back to our side door, we can check latching here within the software. Now we would also need to go back to our Advantech utility like we were talking about earlier and actually change that from low to high latch and stop and restart the I/O supervisor so that it can see the change within the I/O point. I'm going to leave mine just a standard digital input because pulling it once every 1/10 of a second, it's unlikely that there's going to be any type of change that we wouldn't notice. So I'm going to go ahead and uncheck latching. Now there's two settings here in logging and alarm. So basically I want this to be logged anytime it goes high or low, open or closed. But I only want it to go on alarm when the door is opened, when the point is actually armed. Otherwise, if I put it on both for alarm, it would go into an alarm when the door is open and when the door is closed. You may want that on your system, but typically you'll just want it to go into alarm if the door is open. So we'll go ahead and click OK there. And now that input point is configured. Now we're going to go ahead and configure a few other input points on the system. So this is going to be a vestibule glass break. We're going to give this a new I/O type. So we're going to go ahead and say 31, a little bit higher priority than a door contact. And we're going to say this is a type of glass break. Again, our normal state is off. We don't need a recheck count on our system because it's all new. We'll leave our authority level at 0. And our on suffix is glass break alarm. And our off suffix is glass break normal. Go ahead and click OK. We'll select that I/O type. We want to know when this goes both ways, whether alarm and reset, but we only want it to go in alarm if it goes true. Click OK, and we'll create one more type. So our input 3 is going to be a panic alarm. This is a pretty high priority, so I'm going to make this 80. And you don't have to use higher numbers to be high priority. You can reverse it and do lower numbers or higher priority, whatever best suits the needs of your end user. So we'll call this panic alarm. Our on suffix is panic alarm, and our off suffix is panic normal. Okay, we'll select that type. We want to know if it goes both ways, but again, only an alarm on true. These other points, I'm going to go ahead and double click and just disable them so they don't show up in our system. And now we'll jump to our output points. So this output point will be controlling a electric strike on a maintenance door. And we're going to have to go ahead and create a new type for that. So we'll say that this is type 29, just an electric lock. Our on suffix will be door unlocked, and our off suffix will be door locked. Okay, we'll select that type. We want it to be logged whenever it goes either way again. But this one, it's going to be on an unlock schedule, and I don't want the alarm going off every time it kicks off into an unlock schedule, so we're just going to put alarm never because really it's just an electric strike. So we'll click OK there, and again I'm going to go ahead and disable the rest of these outputs so they're not showing up in the system since we're not using them at this point. Disable and disable. Great, now we've created our inputs and our outputs. Now we want to go ahead and create an I/O group. Like we discussed earlier, an I/O group is used for things such as arming and disarming a group of inputs, elevator control, etc. So I already have an I/O group created. It's called our All Modules group, and I have my Atom 6060 underneath it. Now I'm going to go ahead and create an I/O profile. This I/O profile is going to be used with an output business rule to set our maintenance door electric lock to unlock on a schedule. So we'll go ahead and call this maintenance door. Okay. We highlight maintenance door. Now we can see all of our outputs that we have within the system. So we'll go ahead and click our maintenance door output, and we'll leave the rest of them as do not change. Now we have two settings here. We have our reset and we have our priority. The reset can be a number from 0 to 255. If we set it to 0, this will trigger the output, but it will not automatically reset. We'd have to have another trigger within the system to be able to reset that output point. If we set it from 1 to 254, it will trigger that output for that many number of seconds. And if we set it to 255, that's a special setting, and it's used with our output business rules that will reset at the end of the shift. That's what we want, so we'll go ahead and set it to 255. The priority value are used when multiple triggers or actions are altering the state of the output. The highest priority will win. So for example, in elevator control, if we had a card that would override the normal schedules or the normal permissions, then we would put that at a higher priority than the other items that are triggering the outputs. We'll go ahead and leave this at priority 32 because we've got our output business rule that's controlling this, and that's pretty much it. So now that we've got that, we'll go ahead and click our output business rule. First we need to go ahead and create our shift that we're going to use to unlock this door. Right now I just have a 24/7 shift. So we'll go up here to shifts and we'll create a new shift. So we'll call this Monday through Friday. It will be 9 a.m. to 5 p.m. We're going to leave our shift type of normal because we don't want this to unlock on holidays. And we'll go ahead and go Monday, Tuesday, Wednesday, Thursday, Friday. And 09 to 1700. Perfect. Now we have that. Go back to our output business rules. Sometimes in our software you'll see that things don't update right away, so you basically have to close out of that window and then reopen it. So we'll go back to our IO module again. Go to our output business rules, and there is our Monday through Friday. So we'll go ahead and select our profile, make sure our shift is selected, insert this new business rule, and we'll compile it and send it out. And that's all we need to do. The IO supervisor will control locking and unlocking that door on that scheduled time period. So we'll go ahead and close out this window and we'll open up our monitor station. Here we can see the input points that we've created, their current status, and their type. We can also filter by abnormal state, disabled input points. So if I go ahead and trigger one of the inputs, basically putting it into an abnormal state, we see that the side door triggered and it was armed, so the alarm went off. Go ahead and clear that, and then we'll clear the alarm. So now let's go ahead and go to that side door and we'll disarm that input point. And I'm logged in as administrator, so I have a level right of 3, and as we left this at a level of 0, so I can easily manipulate that point. So now if I go and look at my disarm input points, I see my side door. So now when I trigger this input point, we'll see the state change, but our alarm won't show up because the point's been disarmed. So we'll go ahead and rearm this point. Go back to our arm state. We see all of our armed input points and all of our input points there. We can also filter by type. So I can click on here and we can say equal to the IO type that we created, those different numbers. In this scenario, a higher number means a higher priority. We can filter by less than or equal to, or greater than or equal to. So if I wanted to see everything greater than or equal to a glass break, I could select that and it would pull up my glass break and my panic alarm, but not my door contact because that was at a 30. We can also filter by IO group, so if I have multiple buildings with multiple modules, I can create multiple IO groups for all those different modules and I can filter based on that as well. And click on my output tab and I can filter by my outputs the same way, my output types, IO groups, whether the points are armed or disarmed, and that's the monitoring of IO points within the monitoring station. So let's review our objectives. We discussed what IO modules work with Isonas and how to configure them, namely Advantech, Acromag, and C-level modules. And remember, we only work with basic Modbus protocol, not some of the advanced protocols out there. We discussed IO supervisors, IO groups, and output business rules, and we went into the software and configured some of these items. Understand and configure individual inputs and outputs as well as IO types. IO types allow us to easily filter out only the input or output types that we want to see within the monitoring station. Thank you for attending this course and we hope it was beneficial to you. Have a great day.